person is sitting on a sledge at the top of a grassy slope 4 metres above the ground. And our job is to find the speeds that the sledge and the person will have when they reach the bottom of the slope. Now, how do we do that? Well, we can do it with conservation of energy. We know at the top of the slope the person is going to have gravitational potential energy. That's him and the sledge. And we can work that out with an equation which we know. The gravitational potential energy is equal to the mass of the object times the gravitational field strength of the planet, this time being 9.8 newtons per kilogram because we're on the Earth, and h is the vertical height above our reference point, which we take to be the ground. So that's the gravitational potential energy. If there's no friction involved in this lovely grassy slope, then all the potential energy at the top will be converted into kinetic energy at the bottom. That's what we mean by conservation of energy. So to find the kinetic energy at the bottom, we just have to find the potential energy at the top. So gravitational potential energy is EP, as it says there, is equal to mgh. We put in the numbers now. Mass is going to be 60 kilograms. 60 kilograms multiplied by gravitational field strength on the planet, it's 9.8 newtons per kilogram. And we're going to multiply it by the height of 4 meters, 4.0 meters. Now we do that on our calculator, we end up with a value of 2,352. 2,352 watts. Well, the clue is in the units. Kilograms, cancel with kilograms, and you're left with Newton meters. But we know that a Newton meter is the same as a joule, and therefore we know that the gravitational potential energy is 2,350 joules of energy. Now therefore the kinetic energy at the bottom, that'll be exactly the same. It'll be 2,352 joules of kinetic energy at the bottom. And now in a position to work out the speed of the person and the sledge at the bottom of the slope. So we know the kinetic energy of the sledge and the person at the bottom. It's 1/2 mv squared, and it's got a value of 2,352 joules, exactly the same as the potential energy at the top, because no energy has been lost due to work done against friction. So our job now is to rearrange the EK equals 1/2 mv squared so as we can find out the value of V. So we start with the equation. EK is going to equal to 1/2 mv squared. Now to make it easy for ourselves, we want to find the thing we're looking for on the left hand side. So I just need to swap round the equation. 1/2 mv squared is going to equal to EK. And now I can start to rearrange things by undoing the operations. So if I multiply by 1/2 on one side, I multiply by 2 all the way throughout. 2 times 1/2 is going to give us 1, so we've got 1 lot of mv squared is going to be giving us 2 lots of EK. I've multiplied v squared by m, so I've got to divide both sides by m, and if I divide both sides by m, I'm left with v squared equals 2 EK all divided by m. And now all I need to do now is find the square root of v squared to give us v, and that equals the square root of twice the kinetic energy divided by the mass. So there's my expression there, which is very useful, and it pays a lot of good money to learn how to actually work that out from the basic EK equals 1/2 mv squared. It is quite hard, but with practice you can learn how to rearrange it. So all I have to do is put in the numbers to find the speed at the bottom. So V is going to equal to the square root of twice the kinetic energy, which we worked out was 2,352 joules. I'll put a long line around there and a bracket around that. Divided by the mass of the object, that's the person in the sledge, is 60 kilograms. And if I do that on my calculator and don't make a mistake, I'm left with a value of 8.9 meters per second. And that is the speed of the sledge and the person at the bottom, 8.9 meters per second. A small buggy and a person, total mass 60 kilograms, is at the bottom of a hill and travelling with a speed of 6 metres per second. Our job is to find out how high up the hill the buggy will attain. Now, to do that, we use conservation of energy once again. We know the kinetic energy at the bottom, EK, is a half mv squared, and that will be exactly equal to the gravitational potential energy at the top of its journey, EP equals mgh. We know the mass of the buggy and the person, we know the speed of it, so we can work out the energy. So, the kinetic energy at the bottom of the hill is easily worked out. EK equals 1/2 times the mass times the speed squared. So we're going to have 1/2 times the mass, 60, times the speed squared is going to give you 6 squared, which is 36. And we do that in our calculator, we end up with a value of 1080 joules of kinetic energy. So we know that the buggy has that amount of kinetic energy, and that will be the exact amount of energy which will be transferred into gravitational potential energy. So at the top of the flight then, the gravitational potential energy should be exactly the same, 1080 joules of gravitational potential energy. That's assuming no energy has been lost, because we assume there's no friction in this magical hill. So how do we find the height again? Well, we start with our equation. We know it's going to be EP, gravitational potential energy, is mgh. I'm going to put the mgh on the left hand side to make it easy for us to change things. And now I can divide things through to find h on its own. It's just simply going to be the gravitational potential energy divided by the m and the g. And that's how I find out the height in which the cart arrived at. So we'll do this down here. H is going to equal to EP. That was the kinetic energy originally, which has now been changed into gravitational potential energy. That's 1080 joules divided by the mass, which is 60, multiplied by the gravitational field strength, 9.8. So if we do that in our calculator, we find out that the little trolley, the little cart, reached a vertical height of 1.8 metres. So here would be 1.8 metres vertically up the slope. If we knew the angle of the slope, we could use some trick to find the distance gone up the slope in terms of the ground. So once again, we're using conservation of energy, gravitational potential energy, kinetic energy interchanging to find the height or to find the speed of an object. Now, here's an interesting problem. Have you ever wondered those footballers who, when they score a goal and celebrate by sliding along the grass on their knees? This is a thing which happens quite a lot in football when goals are scored. Here we have the great Cristiano Ronaldo sliding along, and the length of his slide is 4 metres. And we estimate that he started his slide, he was travelling with a speed of 3 metres per second. He's got a mass of 70 kilograms, and our problem is this. Can we find out the frictional force which brought him to a halt after 4 metres? Well, of course we can. It's all down to conservation of energy. We know fine well at the beginning of his slide he's going to have a certain amount of kinetic energy, and that's going to equal to 1/2 mv squared. Now that kinetic energy will be taken away from him because, as you know, his displacement is down this way and the force of friction is going to be in the opposite direction. Now that must mean the force of friction is going to do negative work on Cristiano and bring him to a halt. Rather than increase his energy, it's going to decrease his kinetic energy until it gets to zero. That's because the force and the displacement are acting in the opposite directions. Negative work is being done. So these are the two things you need to know. We know the kinetic energy and we know the work done in terms of just sizes or magnitudes is going to be equal to the force, the frictional force, times the distance that force was acting on. In this case it's 4 metres. So let's get an idea of the friction force of the grass. Well, first of all, let's work out the kinetic energy of Cristiano. So the kinetic energy is EK, is 1/2 times 70 times 3 squared, which is going to give you a value of 315 joules. So Cristiano Ronaldo has got 315 joules as he begins his slide. Now, the negative work done by the force of friction is going to take that 315 joules away from him, so that must be in fact equal to the work done by the friction force. So EW equals 315 joules. So we put down an equation for that. EW is equal to force times distance, and we want to find the frictional force. Then we have EW divided by the distance is going to give us a value, the size of the frictional force. So that is 315 joules, and we'll write it as Newton meters to joules this time, so you can see the calculation, divided by the distance of 4 meters. And you can see the 2 meters cancel to give you the force of friction units are the newtons. So 315 divided by 4, and that's going to give you a value of about 78 newtons. So the force of friction is 78 newtons in the opposite direction from where Ronaldo is sliding to. And that's how we find the frictional force of any surface.
Physics is wonderful. Physics is cool.